Right away. Students, can you all hear me? Can you hear me, students? Right. Right. Okay. So, good evening for all of you. Today we are going to conduct second session of our pre-A level foundation program. Right. So last week we discussed the first topic, atomic structure. Uh, we discussed 10 MCQs and 5 structured essay questions. Right. So today we have to start from the topic number 2. So let's move to the topic number 2. Uh, Before we go for the questions, before we move to the questions, I will explain what are the things that we have to discuss regarding this topic 2. So what is the topic 2 that they have given? The second topic. So they have given a periodic table. Okay, so this is the second topic to be discussed, periodic table. Now, students, in the first unit also, we are discussing about the periodic table and the periodic trends, right? In unit number 1, atomic structure, we have a theoretical part known as periodic table and periodic trends. So you should know the basic things about the periodic table, right? Some kind of basic things about the periodic table. What are those things? So when we consider the periodic table, the first thing that you have to know is who found the periodic table, right? Who discovered the modern periodic table? If I ask you a question like, who discovered the modern periodic table? What is your answer? Periodic table discovered by the scientist. He is actually a Russian scientist. Yes, Shiva, correct. That is actually Dmitry Mendeleev. Dmitry Mendeleev. Right? So he is actually a Russian scientist. Okay. And the current periodic table is based on which properties? That means the periodic table is based on, remember students, the periodic table is constructed by using these two factors. The first thing is actually atomic number. And the second thing is electronic configuration. Electronic configuration is the second factor that periodic table is constructed. When we analyze the periodic table, how many now? We know that all the elements in the periodic table can be categorized as the physical states, solid, liquids, and gases. So, how many liquids are there in the periodic table? Right? When you consider the liquid elements, what are the liquid elements in the periodic table? First of all, tell me how many. Yes, one is mercury, right? There are two elements. The first one is mercury, okay? Mercury. And the other one is bromine, Br. Mercury and Br, yes. These are the two liquids element in the periodic table. And remember, when you consider the gases, right? So there are two liquids in the periodic table and there are 11 gases in the periodic table. Right? There are 11 gases in the periodic table. So what are the 11 gases? First of all, hydrogen, helium in the first period. So when we move to the second period, we can see nitrogen, oxygen, fluorine, neon. In the third period, we have, we can consider chlorine, right? Argon. Then krypton, xenon, radon. Now count the elements, right? So what are those elements? Hydrogen, helium, nitrogen, carbon, nitrogen, oxygen, fluorine, neon, chlorine, argon, krypton, Kr, xenon, and radon. So then how many elements are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 gases in the periodic table. Understood? So you have to remember them. So there are 2 liquids element in the periodic table and there are 11 gases in the periodic table. And all the other elements are considered as what? Solid elements. Understood? So the next thing, right? So we have to discuss about few important topics, few important things about the periodic table. And when you consider the modern periodic table, right? In this modern periodic table, we can classify the modern periodic table into like this: metals, non-metals, and metalloids. Like this: metals, non-metals, and metalloids. Right? So 80% of the periodic table elements are metals, others are non-metals and metalloids. Right? Most of the elements in the periodic table are metals. We can classify the elements metal, non-metals, and metalloids. Metalloids means what? Metalloids means elements which can show both metal properties and non-metallic properties. Can you remember the staircase that we learned? In O-level time also you may have learned. So there is a staircase, that is the separation of the metals and the non-metals in the periodic table. Right? So elements in the left side of that staircase, those are known as metals. Elements in the right side of the staircase, those are known as non-metals. Right? In this way. So the next thing is actually amphoteric elements. So what does mean by amphoteric elements? Do you know that? What are the amphoteric elements in the periodic table? Right? Amphoteric. The term amphoteric is representing what? Yeah, amphoteric means, remember, they can react with both acids and bases. Right? Amphoteric means they can react with both acids and bases. Yeah, aluminium is one of the examples. Remember, students, in the periodic table, there are 5 amphoteric elements. How many elements are there in the periodic table? How many amphoteric elements are there? 5. So therefore, we can consider that amphoteric elements are, right, starting from beryllium, then aluminium, tin, lead, and zinc. So these are known as what? Amphoteric elements. Beryllium, aluminium, tin, lead, and zinc. These are known as amphoteric elements. Can you understand? Right? Okay, the next thing. When you consider the periodic table, how many, what does mean by periods and what does mean by groups, right? How many periods are there in the periodic table? How many groups are there in the periodic table? We know that period means actually the rows in the periodic table. If you consider the modern periodic table, right, how many rows are there? How many periods are there in the periodic table? Have you seen the modern periodic table? In your resource book, they have given, right? I told you to buy the resource book. In the resource book, they have given the modern periodic table. There are 7 periods, okay? Remember, students, there are 7 periods in the periodic table. The period number is 7. And how many groups are there in the periodic table? In the periodic table, there are 18 groups. So 7 periods and 18 groups are there in the periodic table. Can you understand? And totally, how many elements are there in the periodic table? The total number of elements will be 180. Right? There are 118 elements in the modern periodic table. Understood? And the next thing is actually we can classify these elements in the periodic table as we can have a blockwise classification, right? S, P, D, F. So likewise, blockwise classification now there. right? These 118 elements in the periodic table can be classified as S block, P block, D block, and F block, right? In our syllabus, unit number 6, right? Unit number 6 is considered as chemistry of SPD block elements. We are studying about the chemical properties of S block elements. We are studying about the chemical properties of P block elements. And we are choosing 10 elements in the D block, and we are studying the properties of them. Last week also I told you that the first 10 elements after the atomic number 20, that means scandium to zinc, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. We are studying them under D block, right? So as a summary, these are the things that you have to remember about the periodic table, right? Periodic table is constructed by Dmitry Mendeleev based on the atomic number and the electronic configuration. So there are three states of elements: solid, liquid, and gases. There are two liquids in the periodic table: mercury and bromine. There are 11 gases: hydrogen, helium, nitrogen, oxygen, fluorine, neon, chlorine, argon, krypton, xenon, radon, right? And then we can classify the elements in the periodic table as metals, nonmetals, and metalloids. 80% of the elements in the periodic table are metals, and there are 5 amphoteric elements: beryllium, aluminium, tin, lead, zinc. 7 periods and 18 groups are there. Periods means, remember, these are actually rows, right? They are rows in the periodic table. So group means actually the columns in the periodic table. So there are 18 columns in the periodic table. There are 7 rows in the periodic table. Rows are known as periods and the columns are known as. Then totally there are 118 elements in the periodic table, and we are classifying all the elements blockwise SPDF, right? Okay, so this is a summary. I want to teach you a few other things. Can you please note down these things in your writing book? Take out your writing book and note down these things quickly. While you note down these things, if you have any doubts, put your doubts in the chat box. Okay. Yes. What are the doubts you have? Can the names of the blocks be capital or simple letters, or is the specific way to write them? So normally we are using simple letters, okay? In order to name the group, name the blocks, we are using simple letters, right? By using metalloids, can we conduct electricity? Yes. Now, when you consider silicon, right? Silicon element actually, they can use, right? We can use those elements in order to pass the current electricity, because metalloids means they have both what? Metal properties and non-metal properties. So therefore, we can use. Right, we know that silicon semiconductors are there, right? We are making transistors and everything, right? Electronics you have learned in your O-level time. So we are using them, right? Yes, we can use, of course. Right, okay, done. Shall I erase these things quickly? Huh? Right. Now, students, so I told you that we can classify the elements blockwise in this way. Right. So we know that, so this is the rough sketch of the periodic table. In this way. Okay. So remember, students, this is known as S block of the periodic table. So this is the S block. And this is the D block of the periodic table, right? At the middle. And the right side corner, we can see P block of the periodic table. And this is F block of the periodic table, right? And in the periodic table, you can see that there are 10 elements that we are studying in the periodic table. As I told you here, so we are studying them in the unit number 6, canadium to zinc, right? So those are D block elements. And the next thing is, in the F block, we are categorizing the elements into 2 series. One is lanthanide series. What is it? Lanthanide series. And the other one is actinide series. Lanthanide series and the actinide series. Okay, in this way. So you have to remember this blockwise classification of the periodic table: S block, D block, P block, and F block. Got it? Then, students, in the periodic table, what are the group number 1 elements? Right? You should know the periodic table elements, especially group wise. What are the group number 1 elements? Lithium, sodium, potassium, rubidium, cesium. And we can say francium also. So what are the group number 2 elements? Beryllium, magnesium, calcium, strontium, barium, radium. So these are the group number 2 elements. And then we have group number 17, halogens, right? Group number 17, those elements are known as halogens. Are they? Group number 17 elements are known as halogens. Halogens. Okay. So what are the halogens? Fluorine, chlorine, bromine, iodine, astatine. Right? In this way. Group number 18 elements. For group number 18, we are giving a name. So group number 18 elements are known as, you know the name. Tell me. Group number 18 elements are known as? What are they exactly? Halogens means, yeah, that is a common name that we are giving for the group number 17 specially. Right? Halo elements. Right? Halo means actually fluoro, chloro, bromo, iodo. So those are known as halogens. For the group number 17 elements, we have given a specific name like halogens, halo elements. Understood? Right? Tell me group number 18 elements. They are known as? Yes, group number 18 elements. They are known as? What are they? Yes, they are known as noble gases, right? They are known as noble gases, or else we are giving a name like rare gases. Okay, noble gases or rare gases. So, what are the noble gases? Right? Helium, neon, argon, krypton, xenon, radon. These are known as noble gases. Right? So you have to remember specifically these groups, okay? Group number 1 elements. For the group number 1 elements, we are giving a name like alkali metals. Alkali metals of the periodic table. Okay. For the group number 2, we are giving a name like alkaline earth metals. What are they? They are known as alkaline earth metals. Understood? Group number 1 elements are known as alkali metals. Group number 2 elements are known as alkaline earth metals. Group number 17 elements are known as halogens. Group number 18 elements are known as noble gases, rare gases. Understood? Noble gases are having an inert configuration because that means their electronic configuration is very stable, right? So therefore, group number 18 elements are not forming chemical bonds, especially helium, neon, argon. But when the number of electrons are increasing, krypton, xenon-like elements can make bonds. Understood? In that way. So you have to remember them, okay? Group number 1, 2, 17, and 18, right? Okay, quickly note down these things. If you have any doubts, you can ask me, right? Right, okay. Those are known as alkaline earth metals, okay? Alkaline earth metals because we can extract these elements from the earth crust, right? So that's why they have given alkaline earth metals, right? Why they have given a name like alkaline? Alkaline means actually they are basic. That means those elements are having basic properties. Alkaline earth metals because we can extract them from the earth easily. Understood? That means mostly carbonate compounds, right? Oxides. Likewise, we can extract them from the earth. Right. Now, the next thing is look at the next one, right? So the next thing, let's go group wise classification again, right? Group number one, group number two. In O levels, you learn that after group number two, it is three. But remember, students, in A level, actually, we are learning exactly. They are group number 13, okay? Group number 13, group number 14, 15, 16, 17, and group number 18. So we can consider lithium, sodium, potassium, rubidium, cesium. And here we have beryllium, magnesium, calcium, strontium, barium. Group number 13, boron, aluminium, silicon, sorry, boron, aluminium, gallium, indium, thallium. Then group number 14, carbon, silicon, germanium, tin, lead, right? Then group number 15, nitrogen, phosphorus, arsenic, antimony, bismuth. Oxygen, sulfur, selenium, tellurium, polonium. Group number 17, fluorine, chlorine, bromine, iodine, astatine. So here we have neon, argon, krypton, xenon, and radon. Right? So we can classify the elements group wise in this way. So here you can see that again. Don't worry, again, we are learning these things under unit number 6, okay? Chemistry of SPD block elements. So you have to remember the periodic table in this way. Got it? You have to remember this periodic table in this way. Right. Again, what are the group number 1 elements? Lithium, sodium, potassium, rubidium, cesium. Then group number 2, beryllium, magnesium, calcium, strontium, barium. Group number 13, boron, aluminium, gallium, indium, thallium. Group number 14, carbon, silicon, germanium, tin, lead. Group number 15, nitrogen, phosphorus, arsenic, antimony, bismuth. Group number 16, oxygen, sulfur, selenium, tellurium, polonium. Group number 17, fluorine, chlorine, bromine, iodine, astatine. Group number 18, neon, argon, krypton, xenon, radon. In this way, right? So as I told you, now we can classify the elements. Okay, we can classify the elements: metals, non-metals, and metalloids. So where that the periodic table is separating, can you remember that? The staircase, I told you that, right? It's like this, right? This is the staircase. So this is the staircase where the metals and non-metals are separated. And remember, boron, silicon, germanium, arsenic, antimony, tellurium, polonium. So these are actually considered as metalloids. Understood? Right? The elements actually lie on the staircase, right? Nearby staircase is considered as metalloids. Right? So left side elements are known as metals and the right side elements are known as non-metals. Can you understand? And in this periodic table, you can see that beryllium is there. I told you that beryllium is beryllium is one of the amphoteric elements, right? And can you see that aluminium? Aluminium is amphoteric. Tin lead, these two also amphoteric. And the other amphoteric elements is in the D block, right? Beryllium, aluminium, tin lead. So these are actually amphoteric elements. After that, bromine is a liquid. I told you that. Bromine is a liquid element. See, this is the one of the liquid element. So neon, argon, krypton, xenon, these are actually noble gases. Right? Group number 17, these are the halogens. Right? Group number 1, alkali metals. Group number 2, alkaline earth metals. Right? Like this. Here's the summary. Understood? We are drawing the complete periodic table in the class, right? When we are studying the periodic table in unit number 1, atomic structure. Okay, we have to draw it. Okay, now quickly complete this one. If you have any doubts, you can ask me, students. Okay. Right, okay, done. Okay, now let's move to the questions that they have given from the second topic periodic table in the tutorial. Take the PDF, students, page number 5. And students, you will get the tutorials next week. I told you that. So I thought to send you the NIT number 1 part 1 tut also. So today I uploaded the PDF of the photo of the tut to the WhatsApp group. So this is the tut that we have to discuss on the unit number 1. So this is actually very interesting tut. That means some of the interesting facts we are going to discuss on the unit number 1. Okay. So you will get this tutorial. Okay. Those who give the details for admin Amasha. So you will get this tut and this tut both along with that file. Okay. Those who didn't give the details to admin Amasha, so please give the details and I can send you a tutorial. Right. Now let's go to the MCQ questions. Right. MCQs. Question number 1. The modern periodic table is arranged in order of increasing what? What is the answer? Yes, it is atomic number. So therefore, question number 1, answer is B. Easy. Question number 2. The horizontal row in the periodic table is called what? Yes, horizontal row is known as period. That's very easy, right? Go for the next question. Number 3. Elements in the same group have same number of protons, same number of valence electrons, same atomic number, and the same mass. What do you think? Students, now when you consider group number 1 elements, right? Lithium, sodium, potassium, right? So the electronic configuration that you learn in your O-level time is here 2,1, here 2,8,1, and here 2,8,8,1, right? So what is the common thing that you see in the group wise elements? The common thing that you see is the valence electrons, right? So the valence electron is actually always what? It's common. Always in the group number 1 elements, the valential electron. Valential electron means the last principal energy level. The last energy level is always containing 1 electron. So therefore here, same number of valence electrons. So therefore question number 3 answer is B. Right? Number 4. Which of the following is a noble gas? Oxygen, helium, neon, both B and C. Helium and neon, right? Helium and neon, both B and C. Therefore, answer is D. Answer is D, right? Question number 5. Which element belongs to group number 1? What are the group number 1 element? Lithium, sodium, potassium, rubidium, cesium, francium. So therefore, here they have given sodium, calcium, aluminium, nitrogen. So answer is A, sodium. Right? Across a period, from left to right, metallic character generally, what do you think? Disappears? No, it's not disappearing, right? We can't say disappearing. Remember, we know that in the left side, now in the periodic table, left, center, and the right in the periodic table, right? In the left side, you can see metals. In the center, at center, we can see metalloids. At right side, you can see non-metals. Non-metals, okay? Metals, metalloids, and non-metals in this way. Understood? Metals, metalloids, and non-metals. So, so therefore, what will happen to the metallic character? So we can say that for this direction from left to right, across a period from left to right, across a period from left to right, what will happen to the atomic radius? Sorry, metallic character. Metallic character is decreasing. Metallic character decreases, right? It is decreasing in this way. So therefore, question number 6, what is the answer? Answer is B. Question number 7. Okay. Noble gases, noble gases actually, we can say that noble gases are not forming chemical bonds. So therefore, they have neither metallic character nor non-metallic character. So that means noble gases stays here what? Neutral. Understood? So they are not also falling to the metalloids. Okay, metalloids means both metallic and non-metallic properties. Metallic and non-metallic. So noble gases stays here what? They are staying here as neutral because we are not considering that one since they are not forming any chemical bonds. Understood? Right? So therefore, by forgetting that, when you consider other elements, we can say that the general behavior is actually metallic characteristic decrease. Okay, right. Because students, now we can't say that now. Yes, sometimes you might think that whether all the elements, right, whether all the elements in the periodic table after that staircase, right side, whether all the elements are non-metals. No, the staircase is actually going like this, right? In the periodic table, the staircase is going like this. Even in the non-metal side, the down element is a metal. See, now this is actually, now from here onwards, all the elements are considered as non-metals, no? Sorry. From here onwards, all the elements are non-metals. But even when you consider the group wise, the down element is metal. Understood? So therefore, we can't say that the metallic character is completely disappearing. It is decreasing, okay? Right. Question number 7. Down group number 1, reactivity. What will happen? Down group number 1, is reactivity increasing or decreasing? And how do you explain that one? Yes, I need the answers from you. Let's see. Reactivity is increasing, decreasing. What is your opinion? Yeah, Nilukshika, you are correct. What about the others? Yeah, Rana, you are correct. Shimak, good try. Remember, students, the reactivity is increasing, down group, right? Yeah, Sudesh, good try. Remember, down the group, the reactivity is increasing, right? We have lithium, sodium, potassium, rubidium, cesium. Remember, just imagine you put small piece of lithium and a small piece of cesium to water, which will react, right? Cesium will react explosively. It's very dangerous. But lithium is also reacting. So it will react very slowly. With ignition, it can react, but not much as cesium or rubidium or potassium or sodium. So therefore, we can say that down the group reactivity increases. Okay, reactivity increases down the group. Understood? So this can be explained by the ionization energy also, right? So what do you think about the ionization energy? Ionization energy, is it increasing or decreasing down the group? right? That means ability to ionize, right? Ability to ionize means they are ready to form bonds. So remember students, yeah, ionizing energy is decreasing, right? Ionizing energy decreases. Since that ionization energy is decreasing, what will happen? The reactivity is increasing. Okay. Down the group, the radius is increasing, students, like this. The atomic radius is increasing. Therefore, now cesium-like elements can release the electrons easily than the other elements. That means it's ionizing easily. Ionizing means they are ready to react. Therefore, what will happen to the reactivity? Reactivity is increasing. Understood? So therefore, we can consider down group number 1 reactivity is increasing. So question number 7, here answer is simple A. Right, okay. So therefore, question number 7 answer is A. Which is a halogen, right? Which is a halogen. Now, one of you asked me that why these are known as halogens, right? The name halogens, right? Remember, students, these terms are actually Greek words, right? This halogen is actually a Greek word. Normally, halogens are actually producing salts, right? For an example, silver bromide, right? Lead chloride, sodium chloride. Okay, so that's the salt, famous salt that we know. Potassium fluoride. Likewise, these are actually salts. You can see that the halogen elements are existing anions in these compounds. So halo means salt form. That means that is the salt nature, right? So gen means actually producing, right? So that means salt producing elements are known as halogens. That's how the term halogen is. Okay, so that's a Greek term. So just remember that one. Okay, it's not a big deal. So anyhow, question number 8, which is a halogen. So our answer should be simple A, chlorine. Question number 8 answer is A. Elements in group number 17 forms iron with a charge of, very easy, group number 17, right? Group number 17 is always producing anions. Fluorine is producing F minus by gaining 1 electron. Chlorine is producing chloride by gaining 1 electron. Bromine is producing bromide by gaining 1 electron. Iodine is producing I minus by gaining 1 electron. Understood? So therefore, always halogens are producing. Group number 17, they have charge -1. Answer is C. Number 10, the number of valence electrons in the group number 2. Number of valence electrons in the group number 2. In group number 1, you can say that 1 in the valence shell, there are only 1. In the group number 2, 2, right? So there are 2. So here answer is B. Question number 10, answer is B. Now these are the MCQs, easy MCQs that they have given. Do you have any doubts there? Raise your hand, those who understood that. Raise your hand, those who understood the discussion of the MCQs. Do you have any doubts there? If you have any doubts, you can ask me. Right, okay, good. Right. Now let's move to the structured essay questions. Right. Now let's move to the structured questions. Okay. So question number one. What information can be obtained from a period number and group number? Right. So here, structured questions. Question number one. What information can be obtained from a period number and the group number? First, the period number of the periodic table is representing, right, number of energy levels, right? Number of energy levels, number of shells. Now look at the electronic configuration of sodium, 281. So that means there are three energy levels, right? In A levels, we are writing configuration 1s2, 2s2, 2p6, 3s1. These are the two electrons in the first principal energy level. These are the 8 electrons in the second principal energy level. So these are the electrons in the third principal energy level. So therefore, sodium belongs to the third period of the periodic table. So therefore, the period number is giving what number of energy levels. Then group, they're asking group number and the periodic number. Remember, group is representing the valence electrons. Valence electrons, right? Now look at magnesium configuration. you have learned in O levels 282, but its configuration is 1s2, 2s2, 2p6, 3s2. So in the valence shell, there are 2 electrons. There are 2 electrons in the valence shell. So that means the group number is representing magnesium belongs to group number 2, right? Sodium belongs to group number 1. So the valence shell electrons is representing what? That particular electron belongs to which group? Understood? Question number 2. Question number 2. Explain the trend in atomic size across a period and down a group. Right? Explain the trend in atomic size across a period and down the group. Okay. So in unit number 1, we are learning this theory. Actually, we have to discuss about atomic trends. Periodic trends. Periodic trends. Okay, under this topic, we are discussing about atomic radius. Then first ionization energy. First ionization energy. Then we are discussing about the electronegativity. Then we are discussing about electron gain energy. Electron gain energy. So these kind of things. Okay. So how that atomic radius is varying along a period. Remember, students, atomic radius is decreasing along a period like this. Right? Look at this. This is the variation of the atomic radius. Right? Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Understood? So along a period, right, across a period from left to right, atomic radius decreases. Understood? Atomic radius decreasing for this direction. Got it? Then what will happen to the atomic radius down a group, top to bottom? Right? Lithium, sodium, potassium, rubidium, cesium. So top to bottom, what will happen to the atomic radius? So top to bottom atomic radius is increasing down the group. Lithium, sodium, potassium, rubidium, and cesium. So we can say that atomic radius increases down the group. Okay. Along a period from left to right, atomic radius is decreasing. Down the group, top to bottom, atomic radius is increasing. Then explain the trend in atomic size across a period and a down. So we can say that across a period, left to right, atomic radius decreases. And we can say that down a group, atomic radius increases. Okay. So the reasons that we learn these things in the unit number 1, actually the reason is from left to right, the nuclear charge is increasing. Okay. When you consider lithium to neon, the number of protons are increasing. So therefore the nuclear charge is increasing. So when the nuclear charge increases, what will happen to the radius? The radius is decreasing. So here we can consider that down the group atomic radius is increasing because of the number of energy levels, right? Lithium is containing only 2 energy levels, sodium 3, potassium 4, rubidium 5, cesium 6. Since the number of energy levels are increasing, we can say that atomic radius is increasing down the group. So therefore, this is the trend in atomic size, atomic radius across a period and down the group. Okay, it's very easy. Right. Okay. Now let's move to the question number 3. In question number 3, they're asking, compare the chemical reactivity of group number 1 and group number 17 elements, right? So remember, when you consider group number 1, so these are actually known as reactive metals. Okay, so they are actually highly reactive and they are known as reactive metals. And the difference between group number 17 is, group number 1 and group number 17 is, in group number 17, we can see that they are reactive nonmetals. These are reactive metals and these are reactive nonmetals. So group number 1, so they lose 1 electron, right? Lose electrons. And group number 17, they gain electrons in this way. Understood? Right? So that's the difference between the compare the chemical reactivity of group number 1 and group number 17. Group number 1 reactive metals and group number 17 they are reactive nonmetals. Okay. Right. Now let's move to the question number 4. Give 2 examples for each metals and nonmetals. That's very easy, no? We can give two examples for metals and non-metals. So we can consider that two metals, uh, magnesium and aluminium. So what are the non-metals? Phosphorus and sulfur, they are non-metals. Okay. Question number 5. Explain why noble gases are chemically unreactive. Tell me, students, why noble gases, group number 18 elements, they are unreactive. The reason? Group number 18 elements are unreactive. What is the reason behind that? Because of what? Yes, we can consider that they have a stable configuration, right? They have stable electronic configuration. Noble gases, right? Noble gases have a stable electronic configuration, right? So therefore, we can consider they are chemically unreactive. Yeah, because it has a stable configuration. Yes, Nilukshika, correct. Right. So these are the things that we have to discuss on the topic number 2, periodic table. Do you have any doubts there? Anything? Is everything clear? right? Okay. Yes. We are providing the recording of the Zoom session, of course. Okay, now, students, let's move to the next topic. What is the next topic? Topic number 3 is chemical bonding. Let's see. Chemical bonding. So what are the MCQs that you have? Chemical bonds are formed due to what? So when you consider chemical bonds, remember students, in O-level time, you learn that covalent bonds and ionic bonds, right? But in A-levels, we are learning primary interactions and the secondary interactions, okay? Now, I'm not going to discuss about the secondary interactions, but if I consider the primary interactions, so what are the primary interactions? So the primary interactions means we can consider, as we know, the first one is ionic bonds. The second one is covalent bonds. Third one is dative covalent bonds. And the fourth one is metallic bonds. So these are the primary interactions that we have to discuss. Okay. So I will give you a brief introduction about these 4 types, right? So we know that students, ionic bonds means actually they are transferring electrons. Now, sodium metal is producing sodium plus cation by releasing 1 electron. Chlorine is producing Cl minus by gaining 1 electron. So the electrostatic attraction between the cation and anion is known as anionic bond. Understood? The electrostatic attraction between cation and anion is known as ionic bond. Then what about the covalent bonds? Covalent bond means now when there are 2 elements, capital A and capital B, capital A is having 1 electron and capital B is also having 1 electron. So these 2 electrons are shared between the atoms A and B. After they formed, right, that is electron sharing, right? This is actually electron transferring. The difference between, right, difference between ionic bonds and covalent bonds will be ionic bonds are transferring electrons while covalent bonds are sharing electrons. So here capital A is giving 1 electron, capital B is giving 1 electron, they are shared, right? Right now, you haven't learned about the dative covalent bonds. What does mean by dative covalent bonds? So that is also a covalent bond type. That means they are sharing electrons. Dative covalent bonds means they are sharing electrons. But remember, here capital A is having 2 electrons, but B has nothing. Dative means there will be a donor and acceptor. In a normal covalent bond, we know that each element carries 1 electron. But in a dative covalent bond, remember, in a dative covalent bond, one particular element is carrying 2 electrons. So therefore, this is actually what? Donor. And this is actually known as acceptor. Donor and the acceptor. So what will happen? These 2 electrons will be given to capital B and producing a dative covalent bond. Right? Dative covalent bond. That's the thing. Can you understand the difference between covalent bonds and dative covalent bonds? Raise your hand those who understood the difference between covalent bonds and dative covalent bonds. Covalent bonds means, again I'm telling you, right? Listen to this one. Covalent bonds means, remember students, one element is giving one electron and the other one is giving another electron. These two electrons are shared by two elements and forming a bond. Dative covalent bonds means only one particular element is giving lone pair, one particular element is giving electron pair, and the other one has nothing, but these two electrons are shared between both the elements. Then here there will be a donor and an acceptor. The one who donating electron pair is known as donor. The one who accepting the electron pair is known as acceptor. This is actually known as what? Dative covalent bonds. Right? Okay, now you have an idea about ionic bonds, covalent bonds, and dative covalent bonds. What does mean by metallic bonds? Metallic bonds. Do you know about the metallic bonds? Right? You haven't learned these things in O levels, right? You have learned ionic bonds, covalent bonds, but you haven't learned about dative covalent bonds and metallic bonds. So metallic bonds means it's something like this. Now look at this one, Ilu. Now you know what does mean by metals, right? Metals means actually they have electrical conductivity ability, right? They are electrically active, right? They can conduct electricity, they can conduct thermal energy, right? So malleable, right? There are some metallic properties are there now. So when we consider metallic elements, they are producing, right? They are producing metallic bond like this. Now let's consider, let me consider sodium. Sodium is one of the metals that we discuss generally. Sodium is producing sodium plus cation and releasing one electron. So sodium element is producing sodium plus cation by releasing electrons. Sodium is producing sodium plus cation by releasing electrons. Now these are the sodium cations. Look at this. These are the sodium cations. Now sodium cation has released electrons, as I told you. Now these electrons are actually gathered around the sodium plus cations as an electron sea. We consider this one as a sea of electrons. Understood? We can consider this one as a sea of electrons, right? Electron sea. Metallic bonds means metals are producing metal cations by releasing electrons. These electrons are producing an electron sea. So the electrostatic attraction between the electron sea and the metal cation is known as a metallic bond. Metallic bonds can be produced by only metals. So that's why those are known as metallic bonds, right? The name itself is saying that metallic bonds only belongs to metals. Understood? Metallic bonds are produced by metals. What does mean by a metallic bond? Metals are producing cations. Those cations are surrounded by an electron sea. Electrostatic attraction between the cations and that electron sea is known as metallic bond. Raise your hand those who understood the definition for the metallic bonds quickly. Do you understand that? Right? Do you have any doubts there? It's very simple, right? It's very simple. Do you have any doubts there? Okay. Right. Then, so this is the summary, okay? So in A levels, we are learning secondary interactions, right? Dipole-dipole interactions and hydrogen bonds, right? Dipole-induced dipole interactions, ion-dipole interactions, ion-induced dipole interactions, then London forces, right? Likewise, we are discussing about secondary interactions. I'm not going to discuss those things here because we are learning these things in detail under unit number 2, structure and bonding in our syllabus, right? So therefore, this is, for now, this is enough to get a basic idea about the bonds, right? Now let's move to the, and you have learned about the hydrogen bonds, right? You have learned about the hydrogen bonds in O-level time also, right? Hydrogen bonds are very strong, right? Okay, now let's move to the questions. Question number 1. chemical bonds are formed due to proton transfer, neutron sharing, electron transfer or sharing, positron exchange. It's very easy, no? Electron transfer or sharing. Question number 1, answer is C. Question number 2, ionic bonding occurs between two metals, two non-metals, metal and non-metal, metalloid and metal. Yes, Rana, that is the answer, right? Sodium chloride. In the periodic table, we consider sodium is metal. Chlorine is considered as non-metal. Understood? Right? Potassium fluoride. Potassium is a metal and fluorine is considered as a non-metal. Then electrostatic attraction between the cation produced by a metal and anion produced by non-metal is known as an ionic bond. So therefore, ionic bonds are formed between metals and non-metals. Question number 2, answer is C. Question number 2, answer is C. Right? Right. Now let's move to the question number 3. Which compound consists of ionic bonds? What is it? We have water, then sodium chloride, carbon dioxide, and methane. What is it? Sodium chloride, right? H2O, carbon dioxide. We know that water molecule is, it's look like this. Then when we consider sodium chloride, Na plus and Cl minus, that is an ionic bond. Then carbon dioxide. So this is what we consider as carbon dioxide, Lewis structure for carbon dioxide. Then the next one is methane, CH4. So it's like this. Understood? So water, carbon dioxide, methane, all of them are covalent bonds. Sodium chloride is the only ionic bond, B. Question number 4. Covalent bonds involve what? Yeah, we can say that what? Covalent bonds are involving sharing of electrons. Answer is B. Question number 5. The valency of ammonia, nitrogen in ammonia. We know that ammonia, the Lewis structure of ammonia is like this. Students, what does mean by valency? Valency means the bonding capacity. That means how many bonds can produce by this element, right? So nitrogen you can see that in ammonia molecule, nitrogen can produce 3 bonds. So therefore the valency of nitrogen is 3. Then the next one, when you consider hydrogen, what is the valency of hydrogen? It's 1. That is the valency. So valency means the bonding capacity, how many bonds can produce by that particular element. In ammonia, nitrogen's valency is 3. That means answer is C. Question number 5, answer is C. Question number 6. A molecule with polar bonds, right? A molecule with polar bonds. Polarity. So how do you find out that polarity? How do you find out that? Now, when you consider oxygen molecule, this is the oxygen molecule, right? We know that students, there is no electronegativity difference between 2 oxygen atoms. That means there is no polarity. No, there is no electronegativity difference between these 2 oxygen atoms. So therefore, we can consider that there is no polarity between these 2 oxygen atoms. So we consider this molecule is non-polar bond, non-polar covalent molecule. Then when you consider nitrogen molecule, in nitrogen molecule also there is no electronegativity difference, right? What does it mean by the electronegativity? Electronegativity means the ability to pull the bonding electron pair by one element. Can you remember in all our times we learned that Pauling scale? Tell me which element is the most electronegative element in the periodic table? Yeah, that is fluorine. That is fluorine. The second highest one is oxygen, right? So therefore, between nitrogen and nitrogen, there is no electronegativity difference because same element. So therefore, this is non-polar. Okay, non-polar. And what about water molecule? Students, water molecule, when you consider water molecule is not like that. It's a polar molecule. That means here oxygen can pull the electrons. Here also oxygen can pull the electrons in the bond, right? Here oxygen can pull the electrons and here also oxygen can pull the electrons. So therefore, we can consider that there will be a resultant force, right? There will be a resultant force to the upward direction. Understood? Right? We know that when there are 2 forces like this, right? Where will be the resultant force? The resultant force will be for the upward direction. That means the electron pull, that means the polarity of the molecule is for upward direction. Then we consider this molecule is what? Water molecule is a polar molecule. This is a polar molecule. Understood? What about the next one? The next one is carbon dioxide. Carbon dioxide, is it polar or non-polar? Carbon dioxide, polar or non-polar? What do you think? Carbon dioxide is, yeah, it's non-polar because oxygen is pulling electrons for this direction, and here also oxygen pulling electrons for this direction, right? Now just imagine like this. There is an object on a smooth surface, right? We are adding 5 Newton force for right direction and another 5 Newton force for the left direction. Then what will happen to this object? So this object is actually at the rest. That means the resultant force is zero, right? Resultant force is zero. R is zero. No force. So here also oxygen is pulling electrons for this direction. And here also oxygen pulling electrons for this direction. So no polarity. We consider this molecule is non-polar. Got it? We consider this molecule is non-polar. Oxygen non-polar, nitrogen non-polar, carbon dioxide also non-polar, and water molecule is. Then here we can consider that question number 6, answer is C. The molecule with polar bonds, answer is C, H2O. Okay. Right. Okay. Now let's move to the next question. Question number 7. The electron dot structure of HCl shows 1 shared pair, 2 shared pair, 3 shared pair. HCl is easy, no? So HCl means it's like this. So actually it's sharing 1 electron pair. So therefore, question number 7 answer is simple. It's very easy. Question number 8. Metallic bonding can best be described as electron transfer, shared pairs of electrons, positive ions in a sea of delocalized electrons. Yeah, that's the answer. No, I told you that metallic bonds mean what? Metal cations dissolve in an electron sea, sink in the electron sea. So therefore here, eighth one answer is C. Question number 9. Which has the highest melting point? Sodium chloride, water, O2 and methane. What is it? Sodium chloride, water, oxygen and methane. Which one has the highest melting point? Are you sure? Now we know that sodium chloride is ionic bond. Yeah, that's the correct answer. Simple A is the correct answer. Sodium chloride is producing ionic bond. Water molecule, O2, methane, they are producing covalent bonds. Remember, those ionic bonds are very strong. Since ionic bonds are very strong, we can consider that their melting points and boiling points are very high compared to the covalent compounds. So therefore here, question number 9, answer should be A. Understood? Question number 10. What is the answer? Hydrogen bonding is present in ammonia, methane, carbon dioxide, and sodium chloride. What is the answer? Hydrogen bonding is present in ammonia. Remember, students, I'll give you the structure of the hydrogen bonds. Normally, hydrogen bonding means, now for an example here, hydrogen is connected to X element. So X is most of the time nitrogen, oxygen, and fluorine. Okay. Capital X is most of the time nitrogen, oxygen, fluorine. And this is Y element. So hydrogen bonding means the attraction between this hydrogen and element Y. So Y is also what? Electronegative element like nitrogen, oxygen, fluorine. Can you understand? Otherwise, we can't consider them as hydrogen bonds. In order to become hydrogen bonds, X should be nitrogen, oxygen, fluorine. Y should be also nitrogen, oxygen, fluorine. So therefore, the examples for the hydrogen bonding, we can consider hydrogen fluoride, H2O, then ammonia, right? Hydrogen peroxide, okay? Alcohols like methanol, ethanol, right? So these are the examples for the molecules which are having hydrogen bonding, okay? So in order to produce hydrogen bonds, nitrogen, oxygen, fluorine like electronegative elements should be connected to hydrogen atom. So therefore, we have ammonia, methane, carbon dioxide, sodium chloride. Answer should be what? Question number 10, answer is simply ammonia. Right, okay. So do you have any doubts in the questions that we discussed? In the MCQ questions, do you have any doubts, students? All clear? Raise your hand those who understood those things that we discuss? All okay, right? Okay, good. Then let's move to the structured essay questions. So, question number 1, define ionic and covalent bonding. It's very easy. So we know that ionic bonding means simply what? Electron transferring, and they are producing electrostatic forces between cations and anions. So let me write down here in simple form, transfer of electrons. Then what does mean by covalent bonds? Covalent bond means sharing electrons. So therefore we can say that here sharing electrons. Sharing electrons. Okay. Number 2, explain why ionic bonds generally have high melting points. Yes, what is the reason? When you consider ionic bonds and covalent bonds, when you compare ionic bonds and covalent bonds, generally, tell me students, why ionic bonds are having high melting points and boiling points compared to the covalent bonds? The reason? Can anyone tell me the reason? What is the reason behind it? Anyone? Put your answers in the chat box. Why ionic compounds generally have high melting points? The reason? Mobile ions. No, it's not the reason. Remember students, strong electrostatic attraction is the reason. Yes, that's correct. Strong electrostatic attraction. We know that sodium chloride means sodium plus cation and Cl minus anion. The strong electrostatic attraction between sodium plus and Cl minus is considered as ionic bond. Because of this strong electrostatic attraction only, this bond is unbreakable. Unbreakable means hard to break, right? Melting means actually we know that the solid compound is going to convert into a liquid state. So therefore, the temperature required is very high, right? So the reason behind why ionic compounds have generally high melting points and boiling points compared to the covalent bonds, because of the strong electrostatic, because of the strong electrostatic attractions between cations and anions. So that requires more energy to break. So that's why it has high melting point. Very simple. Okay, very simple. Question number 3. Explain the formation of magnesium chloride using electron transfer. So we can consider magnesium chloride means MgCl2. So MgCl2 is made by magnesium 2 plus cation and Cl minus anion. right? So we know that magnesium 2 plus is made by releasing 2 electrons, Mg2 plus and 2 electrons. So chloride is made by gaining 1 electron. So here Cl minus. Okay. Mg2 plus and Cl minus. Then the electrostatic attraction between this magnesium 2 plus and Cl minus is what we consider as ionic bond of magnesium chloride. Right? In your O-level time, you drew the structure like this. Can you remember? That means we are drawing the energy levels like this to in this way, right? Magnesium chloride. So they are transferring electrons and producing a strong electrostatic attraction between the magnesium 2 plus cation and Cl minus, that is known as magnesium chloride ionic bond. Okay. Right, okay. Are we done? Right. Number 4. Draw Lewis structures for water molecule, carbon dioxide, and ammonia. So, question number 4. Lewis structure for water molecule should be like this. And the Lewis structure for carbon dioxide should be like this. And for ammonia, it should be like this. Right? Raise your hand those who drew the Lewis structures correctly in this way. Water, carbon dioxide, and ammonia. Okay. It's very easy, right? It's not hard. Question number 5, they're asking, describe metallic bonding and relate it to properties of metals. So, as I told you, a metallic bond means, right? Metallic bond means what? Metallic bonds means, students, electrostatic attraction between electrostatic attractions between metal cations and electron C. Metal cations and electron C, right? Produced by that metal. So that is what we consider as metallic bond. So because of this, remember, they can conduct electricity. Therefore, conductivity is actually a property of metal, right? And the next thing is actually malleability, right? So we know that this electron C is containing what? These actually known as which kind of electrons? Free electrons, mobile electrons. Understood? This electron C is containing free electrons or else mobile electrons. Mobile electrons means they can pass the current electricity. They are free to move. That's why metals are passing current electricity. Conductivity is high because of these electrons. Right? We have learned that in all our times. Metals are the solid compound of the metal is not transferring the electricity, but when it is in the fused state, that means in the liquid state or in aqueous solutions, they can pass current electricity. Why? Mobile ions, they are separated into ions in the liquid state or in the aqueous state. Then they can pass the current electricity, but in the solid state, so they are not free to move, right? They are stationary. So therefore, they can't pass the current electricity. That is the specialty of metallic bonds. Right, okay. So, students, these are the things that we have to discuss today. Raise your hand, the things that those who understood the things that we discussed today. All clear? Do you have any doubts? If you have any doubts, anything regarding this lesson, you can ask me. All clear? So before the next week class, you will have the 2 tutorials with you. From April month onwards, we are starting unit number 1, theories. Uh, as I told you, during this month, I'm conducting our foundation program, right? So if you have any doubts regarding the class, so our class time is Tuesday 8 p.m. to 11 p.m. from April month onwards. That is our permanent time. It's not going to change, right? So during March month also, we are doing the class from 8 to 10, right? So from April month onwards, we are doing the class 8 to 11 p.m. Okay, Tuesday, it's not changing. And the next thing is, if you have any doubts regarding the class, so please contact our admin. So admin Amasha is there. So you can contact her and you can get the details about the class if you want. Understood? If you have any inquiry, anything. So those are the things that I want to remind you. Okay. So next month we are starting unit number 1. If you have any doubts, contact our admin, and our class time, permanent class time is Tuesday 8 p.m. to 11 p.m. Okay. Yeah, Ritara, you have to know that what is the X element and the Y element. Now, for an example, if you consider that hydrogen fluoride bond, this is the hydrogen bond between HF in this way, right? So this is that X element and this is the Y element. It can be same or it can be different. So that depends on the molecule that we consider. If you consider the water molecule, that can be oxygen, right? That can be nitrogen. So that depending on the molecule that we are taking. In the A-level examination, they are not asking what is X, what is Y, likewise small questions, right? So A-level questions are much more deeper. So yeah, that's the answer. Anything else? When you get the tutorial, you can see that. Did you buy the resource book? I ask you to buy the resource book. So this is the resource book, okay, that you have to buy. Again, I'm telling you that if you definitely you have to buy this one, okay, because this is kind of your textbook. You should have this book with you. Raise your hand those who bought this book. At least you should have the PDF with you, okay? I'll share the PDF with you to WhatsApp group. Right. Anything? Any other doubts? All okay? Right. Okay. Then I'm going to wind up the session for today, students, and we can meet on the next session. Until then, bye bye. Have fun. Good night for all of you. God bless you.